Hello, welcome to Lesson 5, made by the American Institute of Techniques and Management. In this lesson, I will be continuing the previous lesson, Lesson 4, regarding formulas and functions. Before we begin, I would like to address the last topic we had. I have a prepared file for this. We are talking about errors. I would like to tell you a bit more about the errors you can approach in the future. So what kind of errors you can actually see. We spoke a bit about this, but let's talk a bit more. So, division by zero. When you're trying to divide anything by zero, this is one of the types of errors you can actually see. The NA. When a formula or a function inside a formula cannot find the reference data. Name. When text is in a formula is not recognized. Null. When a space was used instead of a comma in formulas that reference multiple ranges. A comma is necessary to separate range references. Num. When a formula has numeric data that is invalid for the operation type. Ref. When reference is invalid. Value. When the wrong type of operand or function argument is used. In the future lessons we will go over probably most of these. But while working with Excel you will probably find yourself actually reaching each and every one of these errors. So for now let's just delete these. Okay, let's zoom out. And let's talk a bit more about the formulas. Well, I will be concentrating on Excel formulas, but covering the money aspect. Since you understand the basic usage of formulas, I want to show you how to work in different ways with them and how to use them. So, Excel is a lot more than a simple adding machine. It has a great tool for working with money values and a number of ways of presenting the amounts. For example, Excel makes it easy for you to make sure that your financial amounts are displayed with 2 decimal points. You can even work with different currencies from around the world. Excel works with money on a cash flow basis. In other words, money amounts are treated either as a cash flow in, money you receive, or a cash flow out, money you put out. Excel represents cash flow in as positive numbers and cash flowed out as negative numbers. For example, when you calculate the payments of a loan, the situation is as follows. The amount of the loan is entered as a positive value because this is the money you'll receive from the bank or whoever is giving you the loan. The monthly payment that Excel calculates is a negative value because this is the money that you'll be paying out. One of Excel's shining strengths is accepting, manipulating, and reporting on monetary data. As such, Excel provides robust formatting from numeric data, including the ability to control the placement of commas and decimals, and even how to format negative values. People are used to seeing money amounts formatted with a current symbol and a certain number of decimal places. In the US and Canada, that is the dollar sign and 2 decimal places. Let's face it, 199.95 looks like money, but 199.9050 does not. Excel makes formatting cells to display money amounts as easy as clicking a button. And I showed you the method before. It's simple. Just change the by clicking each cell, just change the currency of the cell. But suppose you don't want the default currency formatting. Perhaps you're in the US, UK, anywhere in the world actually, and working on a spreadsheet for the London office. You can specify the currency symbol, the number of decimal places, and how negative values are shown by following these steps. Select the cell or the cells you want to format. Right-click the cell and choose Format Cells from the drop-down menu. In the Format Cell dialog box, which probably should show up now, yeah, here it is, select the Number tab as shown in here. So the Number tab is here, and this is what you see. And then you click the currency in the category. So as simple as it goes, we have the negative numbers using the separator, and that's the number. Again, formatting cells, currency. You can choose the currency, any currency you want. As you can see, the vast amount of currency is really mind-blowing, to be honest. And by simply choosing the currency you're interested in, you click OK, and this area is currently shown as currency. Let's just type in 100. Yes, and you see this point has been formatted as a currency. The currency and accounting formats are similar to each other. This is what we spoke before, that the currency and the accounting is very similar, but there are differences. Two separator symbols are typically used. One to separate thousands and the other to separate the decimal part of the value. In the US, commas are used for thousands and the period for the decimal. Other countries have different ways of doing this. In many European countries, for example, the period is used to separate thousands and the comma is used for the decimal. In addition, the currency symbol is often at the end of the number. An amount in euros, for example, may be formatted as, let's say, 12,345,67 euro. That's the difference we spoke before. But, well, in almost all situations, the operating systems local settings result in the proper separators being used automatically. If you need to change the separators for the defaults, do so in the regional and language options in the Windows control panel. Note, these instructions are for computers running on the Windows systems. So I will show you how to change this right now. Let's go to the control panel. You see my control panel right now. And we go to language and regional link. Let me find it first. Yeah, here we go. So you can see my format is for Poland. We can change it for any other we want. So here we choose the we click the additional settings buttons to open the customize format dialog box. Okay, and right now I'm in the currency tab, and here you can see the currency symbols available for me right now. Well, of course, there's a way you can change settings for numbers, currency, dates, and time in the customize formatting dialog. But, well, depending on the version of your system, you will probably have different possibilities for currency settings in your system. Okay, let's go back to Excel. Figuring loan calculations. Loans are part of almost everyone's life. At the present level, you may need to deal with car loans, education loans, and a home mortgage. From a business perspective, companies from the smallest to the largest often use loans to fund new equipment. expansion, and so on. No matter what kind of loan you need, Excel has the tools that permit you to evaluate loans and calculate specific deals. Most loans have the following 5 functions. Loan principal, the amount you're borrowing. For example, if you're interested in a loan of 5,000 euro, then the loan principal is 5,000 euro. Interest rate, the cost to borrow the principal. This is how lenders make money. The interest rate is a fee, so to speak, that a borrower pays to a lender. Usually, but not always, the interest rate is expressed as a percent per year. Payment period. Loans are usually paid back by paying a periodic amount. Most often the period is monthly. Duration of the loan. This is the count of payment periods. For example, a loan may have 36 months of payment. And payment, the amount you pay each payment period. Each of these functions is related to all the other. If you borrow more, your monthly payment will be higher. That's no surprise. If you get a lower interest rate, you may be able to pay off your loan in less time. That may be something to consider. Calculating the payment amount. The PMT function tells you the periodic payment amount for your loan. If you know the principal interest rate and number of payments for a loan, you can use the PMT function to calculate the payment amount. So let's do this right now. Let's enter a loan principal, annual interest rate, and a number of payment periods in separate cells within the worksheet. So let's say our loan principal is for 100,000. Let's change these into euro. 100,000 euro. Here we will put in the annual interest rate. Let's say that the interest rate will be 20%. Let's put in the percent. Oh, that's a bit too much. Yeah, 20% from this. And let's say that the payment length will be for 36 months. Okay, so let's position our cursor somewhere where we want the answer. And let's write in the formula equals PMT. So we begin with the rate. So let's mark the rate right now. And since we want the rate to be calculated by each month, so let's divide this by 12. Let's go to the amount of months. So for us it will be 36 months. And next let's divide this one and let's enter the v, which is the primal value, and let's end it here and let's see what it comes up with. Oh yeah, we still didn't change the currency, and you see the currency being 3,716.36 euro per month. Why was there a red color before? Well, Excel found out in the beginning that he's using, just to show you, well, it was red because Excel found out that it was using zloty, and right now it's supposed to be using euro, and that's the correct currency for the calculation. If you change the value of the last sum and that goes out of your function, you will not see an error, but in the beginning Excel will inform you that it's using a different value, a different currency, so that you know that the calculation is done on a different currency and the end result is also done on a different currency. So your first exercise in this video will be creating a monthly payment for a loan. So what will be the principal value? Let's say for the principal we will use $20,000. We'll change the value. Next. Annual interest rate will be 15%. So to do this, let's probably do it this way rather. And number of periods, we will use 24. Okay. And I want you to do the monthly payment here in this cell. I won't show you how I do it. I want you to go back, watch this equation, and show me the result. I will show it to you next. So the proper answer should be 969 euro. Just to prove it, let's do a different formula. Let's enter equals result times this one, which should show us the amount of euro with interest. So 15% from 20,000 euro. Let's see if it's true. The amount of euro times 1.15. Yeah. The calculation over here also indicates when you abstract from 20,000 euro monthly, the payment is higher because of the changing rates of the amount of money you have. So basically, that's the reason why this value is smaller than this one, but this is the proper answer. Although the PMT function returns the constant periodic payment amount for a loan, note the payment that each payment actually consists of two portions. One portion goes toward reduction, reducing the principal, and the other portion is the interest payment. Okay, calculating interest payments. The IPMT function tells you the interest payment for a given period. In each payment period during a typical loan, the payment consists of a portion set to reduce the principal of the loan, with the other portion of the payment being the interest on the principal. The amount of interest varies payment by payment. In a typical loan, the portion of payment that is interest in highest in the first period and is reduced in each successive period. The IPMT function takes four inputs: the principal, the interest rate, the number of payments for the loan, and the number of payments you are interested in. For example, a loan may have 24 payments and you're interested in how much interest is included in the 12th payment. For some types of loans, the interest is tax deductible, so this information may literally be worth something. Here are the steps for the IMPT function. Enter the following information in separate cells. So let's maybe enter some of those information. Let's use this one. Let's cut it and put it next to our work. Or maybe not cut, but copy. Okay, copy, paste. Great. What we need to add is the number of the actual periods for which you want to calculate the interest. So let's call this the actual NOP. So we want it to be calculated for 10 months. So let's do the positioning and let's write IPMT. So let us begin with the rate that we're interested in. So let's choose the annual interest rate divided by 12 months, the amount of months that we are interested in for the rates, the actual amount of months, and the principal value. Let's format the currency into euro, and as you can see, the amount is 164.86 euro. So the IPMT function returns the interest portion of the amount of the specified payment. The amount will be smaller than the full periodic payment amount. How much smaller depends on which sequential payment is being examined. The remainder of the payment, the part that is not interest, goes to reduce the principal. You can use two optional arguments with the IPMT. So let's see them. Future value, which is the FV, the amount you wish the loan to be worth at the end of its life. The default is 0. Type. This tells the function whether payments are applied at the end of the period or the beginning of the period. A value of 0 indicates the end of the period, and value of 1 indicates the beginning of the period. The default is 0. The principal arguments, when used become the respective 5th and 6th arguments.